motions. So for that, I have taken some photographs directly from the book, and I want to share those uh, concepts. Okay, here is the heading, that is addition of harmonic motion. So what is a harmonic motion? So harmonic motion is a periodic motion where a particle exhibits simple harmonic motion, okay, or where a particle moves to and fro with respect to a mean position. Okay, so the motion should be on either side of the equilibrium line or mean line, just like your simple pendulum or just like your spring mass system. So the basic equation for a single particle, it was x equals to a sine omega t. Okay, so for a simple harmonic motion, the equation will be a sinusoidal motion or curve, and the equation is given by x equals to a sine omega t. So today we will see how to add harmonic motion. So first we will see this for two harmonic motions, okay, and later on we can add more than three, more than two harmonic motions mathematically. Okay, so when we add two harmonic motions of same frequency, we get the resultant motion as harmonic. So this one is very much important. Okay, so the basic equation is x1 a1 sine omega t. So one particle is exhibiting SHM with a frequency of omega. A1 is the amplitude of motion, then small t is the time. Okay, this is instantaneous time, and x is the displacement, total displacement, which is a function of time. So this is the motion for a particle. Then let us consider the other particle is also in simple harmonic motion, and its equation is x2 equals to a2 sine omega t plus phi. So from this equation you can see that the omega term is similar for both the equation. So when this type of equations will be given to you, after summation of these two equations, so you will get a resultant simple harmonic motion. So why you will get a resultant simple harmonic motion? Because its frequency, will be same. Okay, or in other words you can say its angular velocity is same. That is why you are able to add these two simple harmonic motion, and you will definitely get a simple harmonic motion. Means addition of two simple harmonic motion is or results in a simple harmonic motion. Okay, so let us assume two harmonic motions which amplitudes are capital A1 and capital A2, the same frequency omega, and phase difference is phi. So the phase difference, okay, so by this amount of angle phi, this wave or this simple harmonic motion is having a phase angle, okay, to this or with respect to this equation. Okay, or in between these two equation or two motions of the particle, there will be a phase difference of phi. Okay, means suppose if the sine curve is the equation for this particle, then one sine curve which will be, let's say, shifted to the right side. Okay, if it is a positive phi shifted to the right side, then you need to start the motion, or then you need to draw the graph of the particle. Okay, so there will be some horizontal means gap in the graphical representation. Okay, on the mean line or on the this one equilibrium line. Okay, so that is the phase difference. Okay, so how we will add these two equation? So x1 plus x2. So let us consider the final resultant displacement of the equation is x, or the motion is x. So x1 plus x2 for these two equation. Then we need to add these two trigonometric function. Okay, so a1 sine omega t plus capital A2 sine omega t plus phi. So how you will now add these two waves? Now what you can do, that this is sine A plus B. You can compare this to be sine A plus B. So what is sine A plus B? So sine A cos B plus cos A, or sine B cos A. Okay. So this term will be remain same, and the second term it is splitted to these functions. Okay, two terms. Now what you can do, this is sine omega t, here also sine omega t, so you can make sine omega t term common, sine omega t. So here only a1 will be there from this term, and from here a2 cos phi will be remain here. Okay, now a2 sine phi cos omega t will be remain. Okay, on the right side. Okay, plus a2 cos omega t sine phi. Okay, so here you can see sine omega t, and here you can see cos omega t. Here a1 plus a2 cos phi, and here it is sine phi, means in terms of phi and constant it is written, and in terms of phi this function is written. Okay, so now what we will do, this term a1 plus a2 cos phi, so we will be assuming it to be a cos theta. Okay, so what is a? So A is the actually resultant amplitude. So when you will add up these two equations, two sine functions, so one resultant sine function you will get. Okay, so as you know by this definition that this will be a harmonic function. The resultant function will be harmonic function. That is why, as because it is a harmonic function, so it will be having one amplitude, and it will be having one angle also, isn't it? So let's say this is the resultant amplitude. Okay, a, and theta is the angle which the resultant makes. Okay, so with reference with respect to the reference line. Okay, theta. So we need to find out these two values, because we have assumed that this a1 plus a2 cos phi to be a cos theta, and this sine phi a2 sine phi, because cos omega t will be remain there, a2 sine phi will be equals to a sine theta. Okay, so here also a is the amplitude, resultant amplitude, and theta is the angle which makes the resultant makes with the horizontal line or the reference line. Okay, so we will going to find out these values of a and theta. Now what we will do, so we will put the value of a cos theta and a sin theta, or these values here. Okay, so what will happen, so x equals to sine omega t will be remain as it is, sine omega t. So instead of this we will be putting a cos theta, so a cos theta, so a sine omega t cos theta, plus here instead of a2 sine theta, a2 sine phi, so we will be putting a sine theta. Okay, so when we will put, we will get this equation, and this is what sine omega t cos theta plus sine theta cos omega t, means sine a plus b. Okay, so sine omega t plus theta, so a will be remain there, so a will be the resultant amplitude, and theta will be the angle which the resultant makes with the horizontal axis. Okay, now how you will be able to find out the amplitude, resultant amplitude a, and this theta value. So to find out, so what you can do, as you know, sine square theta plus cos square theta equals to 1. So if you just make square on both the sides for these two equations, and if you just add up, then what you will get, cos square theta and sine square theta, which will be equals to 1. Then you will get on the right hand side a square. So here I will be writing directly by squaring equation these and these. Okay, so you can give one number, so equation 3 and 4. By squaring equation 3 and 4, and after adding, we will get a square cos square theta plus a square sin square theta. So if you make it common, a square, then sin square theta plus cos square theta, it will be a square. Okay, so a square I am writing here, a square, then d square, a1 plus a2 cos phi whole square plus a2 sine phi whole square, means a2 square sine square phi. Okay, now if you just split these terms, what you will get? So a1 square a2 square cos square phi a square plus b square plus 2ab cos phi. Okay, so 2 a1 a2 cos phi. Understood? Then this term will be there, so a2 square sine square phi. Here also it is a2 square cos square phi. So this square and this square you will get only a2 square. Okay, so a1 square will be remain there. From this term and this term, sine square phi plus cos square phi will be 1, so a2 square. Then 2 a1 a2 cos phi I have written. Okay, and if you take the square root of this term, then you will get the value of the resultant amplitude A. Okay, so what is A? So A is one part of a simple harmonic motion where it denotes the amplitude of motion or amplitude of vibration. Okay, so now you need to find out the angle. So angle, how will you find out? So sine theta by cos theta, it is what? Tan theta. So A tan theta. Okay, so if you divide, a will be cancelled out, so sine theta by cos theta tan theta. Okay, so this a2 sine phi divided by a1 plus a2 cos phi, so it is written. Okay, so if you divide, if it is number, it is number 3 and it is 4, if you divide 4 by 3 you will get tan theta equals to a2 sine phi divided by a1 plus a2 cos phi. Okay, so if you just take the inverse, tan inverse of this value, then you will get the exact angle. Okay, so this angle is the angle which makes which the resultant motion or resultant vector or resultant vibratory motion makes with the reference line. Okay, so graphically, so how you can show these vectors and how you can find out the resultant vector. Okay, so here what is the resultant vector? So this one is the resultant vector because x is what? X is x1 plus x2. So after doing x1 plus x2, so finally you will get this one. Okay, and if you just combine this one, so you will get a sine function, a sine omega t plus phi. Okay, so x equals to a sine omega t plus phi is the resultant motion, which is a simple harmonic motion for these two individual simple harmonic motion. Understood? So how, if you are asked to find out that what will be the amplitude and what will be the angle which the resultant makes with the reference line, then there are two ways. One is the mathematical way. So this way you can analytically, by doing mathematical calculations, you can find out the resultant amplitude and the angle, okay, of the resultant. Another way is to uh, opting the method of graphical representation. Okay, so how you can find out? By graph. So let us consider two axes, okay, which are mutually perpendicular. So let's say this is one vertical axis, okay, or horizontal axis. This is one horizontal axis, and here it is the vertical axis where the angle is 90 degree. Okay, so reference axis, you can say this is x-axis, this is y-axis. Now what you can do, if your a1 magnitude is given, let's suppose it is a1, its magnitude is this much, this is a1, and its angle is how much? Omega t. So with respect to this reference line, the angle is omega t. Okay, so this is the angle. Okay, this is the angle omega t, and this is the magnitude. So a1, as the magnitude is not given, if it is 10, so we can take 10 centimeter, but as because the magnitude is not given, so we have taken it arbitrarily. So a1, now if you know the angle, so angle is given, it is omega t plus phi. So let us consider it is a little bit bigger angle, so omega t plus phi, so this much is phi. So here it will be your a2 vector. Okay, so here it is assumed that the a2 is a little means it is less than a1. Okay, so a2. So if you just apply parallelogram law of vector addition, means from this tip or head if you draw one parallel vector which is equal in magnitude of this a2, then you will get this vector. Okay, and if you just complete this side also, then there it will be a parallelogram. Okay, so when you will join this diagonal, so you will get the resultant. Okay, so if you just measure this resultant with your scale, so what you will get, so you will get the exact value what you will get by your mathematical calculation. So capital A will be this one from this point to this point. So this will be your the value of the resultant. Okay, and if you just measure the angle, okay, by a protector, so you will get the same angle which you will get by analyzing mathematically from this formula. Okay, so I think this concept is clear to you. Okay, so this is a very simple thing. Okay, only you need to take two reference axes which will be mutually perpendicular. Then you need to take the vectors. Okay, so where the angle may be given. Okay, so with respect to this reference line, you need to take the vectors. Then a1 a2 vector means x1 vector x2 vector. Then after applying the parallelogram law of vector addition, so you will be able to find out this resultant vector, and finally you will be able to measure the angle also. Understood? Okay, so let's solve one problem. So by this method, yeah, so this problem is also taken from the book directly. Okay, so we will see the both the ways. One is the mathematical analysis, another is the graphical presentation. Okay, how to find out the resultant amplitude and the angle. So here add the following harmonic motions analytically, means mathematically, and check the solution graphically. Okay, so two vectors given as x1 equals to 4 cos omega t plus 10 degree, x2 equal to 6 sine omega t plus 60 degree. So from this equation, it is very much clear that the two motions are simple harmonic motion, because I have told you that the sine and cosine functions are simple harmonic functions. Okay, where 4 is your amplitude of motion for the first motion, and 6 is the amplitude for the second wave. Okay, or the motion. Okay, so how we will be doing this one? So earlier the resultant displacement or equation was x equals to a sine omega t plus phi. Okay, so now I have taken it to be, or omega t plus theta. Earlier it is theta, now here it is taken as alpha. So if you do not take this one also, then also you can calculate, no problem. So x equals to x1 plus x2. Okay, so for this they have written a sine omega t plus alpha here. Okay, and they have splitted this term a sine omega t plus alpha, sine omega t cos alpha, and cos omega t sine alpha. Okay, but one thing you should notice here, here it is cos function. Okay, here it is not sine function. Okay, so when you will add up, so you need to be a little bit careful in applying the formula, because earlier it was sine function, sine and sine. That is why it was very much simple. So it will be also simple, but you need to see the formula how to split the sine function and cosine function. Okay, let's move forward. So now for when you will just add up, so x equals to x1 plus x2. So what is x? X equals to a sine omega t plus alpha. So just you split this one. Then for x1 you will write this one, for x2 you will be writing this one. So we will split again this cos function and sine function. So cos omega t cos 10 degree, because cos a plus cos b is what? Cos a cos b minus sin a sin b. So you need to be careful. That is why I have told you. Okay, so cos a plus b equals to cos a cos b minus sin a sin b, and cos a minus b equals to cos a cos b plus sin a sin b. That thing you need to remember. Okay, so when you are positive, it will be negative. Okay, for cos function. So cos omega t cos 10 degree minus, as because 4 is there, so 4 it is written sine omega t sine 10 degree, plus it is sine function, no problem, plus 6 sine omega t cos 60 degree, and cos omega t sine 60 degree, and 6 will be there. Okay, so now you need to find out the value from the calculator. So in earlier case, what we have it was there a sine, so sine omega t will come out a cos alpha, then cos omega t, so a sine alpha. Okay, so what actually we will be doing, we will be comparing the coefficient on the left hand side and right hand side. Okay, so here after you calculate from the calculator, so cos 10 degree, so it will be having some value. Okay, so sine omega t, you can make common sine omega t from this long expression. So sine omega t minus 4 sine 10 degree plus 6 cos 60 degree. Okay, if you make sine omega t common, so it will be you will get this one. Then cos omega t. So why actually you are taking this common? To compare it to the left hand side, so you are making it common. Okay, sine omega t, then cos omega t they have taken, so you will be able to write this expression. Okay, now you need to find out the values from the calculator. Minus 4 sine 10 degree plus 6 cos 60 degree, so you will get this value. Okay, so just you can use calculator to see the correctness of the problem. So then cos omega t for cos 10 degree, so you will get this value 6 sine 60 degree, this value. Okay, so sine 2.305 sine omega t plus 9.135 cos omega t. So now how you will be able to get the value of the resultant amplitude and resultant angle? So this will be because left hand side equals to right hand side, and here the coefficients will be equal because the sine function and the cosine functions are same, sine omega t sine omega t. That means a cos alpha will be equals to 2.305 and a sine alpha will be equals to 9.135, isn't it? So mathematically we can write that a cos alpha equals to this, a sine alpha equals to this. So how you will be able to find out the amplitude, final amplitude or the resultant amplitude? So if you just square on both the sides, okay, of these two equations or equation 1 and 2, then after adding, so you will get a square equals to 2.305 whole square plus 9.135 whole square. So after taking the square root, so you'll be able to get it to be 9.42. Okay, then after dividing this equation by this, okay, 2 by 1, so you will be able to get sine by cos 10. So a will be cancelled out, 9.135 divided by 2.305, and if you just take the inverse of 10 angle, then you will get the value of alpha. Okay, so alpha will be 75.83, approximately it is 76 degree. Okay, so you will be you will have to write this one. Okay, 75.838 degree up to 3 decimal or up to 4 decimal. So if you will write, then it will be good. Okay, so this is the analytical way or the mathematical way to find out the resultant amplitude and the angle. Okay, now the same problem can be solved by graphical method also. Okay, just like the previous example, means previous general concept. So how you will be able to do that? So first you will be taking the reference line. Okay, so here OX and OY, the procedure is written, but I will just tell you thoroughly. So, okay, so the first graph was given as this one. Here it is taken as x2, no problem, because the angle is more, because see, x1 was given as 4 cos omega t plus 10 degree. Okay, it was x1, but here it is taken x2, no problem. It is also correct. Why it is considered to be x2, I will tell you later. So 4 cos omega t plus 10 degree, so it is cos function. So to plot it graphically, so if the two functions are equal, then it is easier actually. That's why we will convert this cos to sine. So when we will convert this cos to sine, okay, so because these two functions are complementary functions, then we need to add 90 degree. Okay, so cos omega t plus 10 degree equals to sine omega t plus 100 plus 90 will be added. Okay, so sine pi by sine pi by 2 will be, okay, pi by 2 angle will be added to this angle omega t plus 90 degree. Okay, so 100 degree. So as because this angle is 60 degree and 100 degree, 100 degree is more than this angle, that is why it is taken as x2. Okay, so you can take it x1 also, no problem, but as because this will come first, okay, in this drawing, so that is why the second sine function is taken as x1. Okay, no problem. So you can write x2 also. So here this x1, so taken as 6. So 6 you can take any scale, okay, for this graphical representation. So for 6 unit, you can say 6 centimeter. Okay, so 1 unit will be equals to 1 centimeter. So 6 from here to here, 6 unit it is drawn, 6 centimeter it is drawn. Okay, then arrowhead is given. Anywhere you can give the arrowhead, but here on the head if you are given, then it is more correct. Okay, it is exact actually way to represent the vector. Okay, now the second curve which is having amplitude of 4. Okay, so from here we will draw 4 at an angle of 100 degrees. So earlier the first vector was at an angle of 60 degree. Okay, now the angle will be 100 degrees. So this is 90 degree, so 10 degree we will add here. Okay, and then we will draw this 4. Okay, 4 unit or 4 centimeter graph, okay, or straight line here, okay, by giving one arrowhead, this vector. So there you need to write that 1 unit equals to 1 centimeter. This is the scale. Now what you will be doing, so you will be applying the parallelogram law of vector addition. So from this head, so you will be drawing one line which will be parallel. Okay, and then from here you will be drawing one line parallel to this vector OB, okay, or x1 vector. So they will meet at this point, and this point will be the other corner, okay, of this diagonal. So if you just join it, so this line will give you the resultant vector, or the resultant amplitude of the simple harmonic motion. Okay, so this is A, capital A, and if you just measure this angle, so it will be 75 point how much, so 838. Okay, or in graphical method it may not be 75.83, it may be 76 also, or it may be 76.5 also. So plus minus 10% error, it is considerable, but your depiction in the graphical method should be exact. Okay, and you should use sharp pencils, okay, and good quality protractor and scale, okay, to plot all these vectors and to measure all the dimension. So finally you will be able to get the exact result what you got in the mathematical analysis. Understood? So this, I think this is not that tough. Only you need to be careful about your vectors or the motions, equations of motions which will be given. Here it was cos. Okay, so if you just overlook this one, then it may be a mistake. Okay, so that is the thing. So dear students, I think now you will be able to add to harmonic motion graphically as well as mathematically, and you will be able to find out the resultant amplitude and resultant angle, okay, or the angle which makes the resultant with the this one reference line. Okay, so there is another example. So I will share this in your, okay, so here there is another example. So just by using the same concept, so you'll be able to plot this one. Okay, so this is one homework for you. You just the solution is also there, so you can just you can just add these two vectors, given vectors. Okay, and you will be able to get the resultant and this one magnitude of the amplitude and the angle. Okay, so thank you, dear students. I will be sharing this PDF file, okay, in the WhatsApp group as well as in the Google Classroom. Okay, and this video also I'll be sharing. So if you have any doubt or queries, you can ask anything. Avinash, Balam, Tamo, Ansuman, Dizras, Bebeto, Ricolo. Actually, I saw Ansuman in every class, most of the classes. He is the first person to join the class. Okay, so as he is punctual, that's why I am actually mentioning his name. Okay, others are also there, but every time actually when I just open the link to you, so he is the first person for most of my classes. Okay, so thank you, dear students. So I will be uploading it in the Google Classroom. Just if you have any doubt, so by today itself, okay, or by the in the evening time, so you can post your doubts, okay, and you can solve the third problem or the second problem in the PDF file. Okay, thank you. You can leave the meeting now.